Hey guys, welcome back to the ad hoc workbench. Eventually, don't you worry, I will get around to setting up a full workbench, but I really want to dive into and get some of these projects done. So, what I'm working on right now is one of the Motorola VT-71 chassis. I've got two of them to restore. I showed you a preview in an earlier video where I tested the picture tubes and took a quick look at the chassis. Well, I was really itching to get working on these, so I've already actually started working on this one. And this is the one that had actually already been recapped. And, well, I wanted to show you where I was at with it and some of the strange things I found along the way. So the first thing that struck me odd was this. Clearly that was not original. Well, what I suspected was it was part of the ballast replacement, because this had no ballast in it. Normally there would be a metal tube here. Well, here's the other chassis I'm going to be working on, and here you can see the innards of it. There are several resistive elements on mica sheets, and they being cased in a protective perforated metal shield. There's also a glass type, but that was aftermarket, and you know, run into too many of those. Well, those are no longer available, so people have to make up their own when they're restoring these sets, assuming the originals are bad, and they so very often are. Now, I did a video where I experimented with a number of different types of ballast replacements using both straight-up power resistors or AC dropping resistors, or this one, which is a diode dropper. This happened to just be left over from when I did those experiments, so I think I'll try using this one when I get around to powering the setup, so I'll go in there, something like that. I'll talk about why you need that a bit later. I've already done a bunch of videos on these VT-71 chassis, so I don't want to go into too much detail. If you really want to see a detailed overview of one, I suggest you watch my Friday night restoration, where I went through one of these in one night and got it working. But without further ado, I'm going to flip this over and show you what I found underneath. Alrighty, so here's a bunch of stuff I already took out of the set. Still got some of the work that was done still in here, like this blue cap here. And some of the work is my new stuff, like this guy here, and this, and this. Now, the reason I know, or suspect when this was worked on, is because these had already been replaced. These are 5 high voltage caps that are always bad in these sets. Well, they have a date code, 8417. That would be the 17th week of 1984. So that's the earliest this set could have possibly been worked on. And if I look hard, I can probably find date codes on some of the other parts as well. At any rate, 8008, probably from 1980. Well, these are made by Sprague. They're plastic film, very likely still good, and they're also rated for 8,000 volts versus the originals, which were rated for 6,000. So I left them in. But here's thing number one. 2 of these should be .001s, but all 5 of these are .0047s. I don't think that's going to be a problem, but something to keep in mind if there's any kind of horizontal issues. I may need to go with a smaller value on those. Now, up here were carbon comp resistors. This is a high voltage divider running off the high voltage rectifier socket here and going all around. It's a rather convoluted circuit. Well, I found several of those that were really off value, so I went ahead and replaced all of them. Here's part of that divider string. Now, these are not ordinary resistors. These are actually high voltage resistors rated for around 3,500 volts. And the reason they strung a bunch of these in series is that the resistors do have a voltage rating. Originally they used 2-watt resistors, which I think are usually good for 750 volts or thereabouts, and I think Motorola pushed that past the 750 a little bit. But seeing as how these are rated for much higher voltage, I probably could have gotten away with even just maybe 1 resistor. instead of these 3 or 4 in series. But hey, that would just confuse somebody down the line, so I just replaced them with the original values. Down in here, a bunch of work had been done. This is typically a problematic area. It's a horizontal oscillator. So the original mica caps were gone, and what I found in their place were, well, these guys. Oddball values were there originally. 900 picofarad, and, well, 680 isn't so odd, but whoever worked on this had to put some in parallel to get the right value. Well, luckily I had the right values on hand, so that's what these 2 new yellow guys are here. And this is horizontal oscillator, typically a problematic circuit, so I just went ahead and replaced it all with modern, reliable name brand components. And I started working my way this way. So let's jump over to the ballast for a bit. That is what was in this socket. So what was that power resistor about that was up in here? Well, part of the ballast is for the tubes. The tubes are wired in series, but there's too many tubes to just do one series string and running off a 117. But if you split it into 2 strings, there aren't enough tubes to add up to 117 volts. So what they did is they made 2 strings that were roughly equal, around 80 volts as memory serves. And then they put 2 dropping resistors of 105 ohms. Those would go inside this ballast. Well, what this guy did is he connected these 2 points and used a single power resistor. That's what that one was up on top of the chassis. However, oh, it's still up there. It doesn't really work. I mean, if that was possible, I think they would have done it back then. You really want to let the 2 strings run independently, and they kind of equalize out as the tubes heat up and so on. But also the value used was too low. I think it was around a 30 ohm resistor. There was nothing in place at the 37 ohm. And 200 ohm, I believe there's a 200 ohm power resistor buried in here somewhere. Yeah, down in there. Or 240 ohms, actually. So, that makes me wonder, did this ever work with the work that had been done? Certainly without that 37 ohm resistor, it certainly wouldn't have. And using too low a value and connected to the 2 filament strings together, I don't know. At least the picture tube is still good, so I didn't get ruined. It's got a nice set of tubes in it. They look to be new. Like here's the SL7 tungsol. Typically after these are used for a while, they develop silver spots above the elements, and this does not. The other tubes all look really good too. So somebody may have invested a lot of effort into restoring this. One place they did take a lot of shortcuts though was the other parts. Here's a typical example where they used a box-style plastic film cap. Nothing wrong with them per se, but they come with very short leads. They're made for mounting on circuit boards, so they had to run extension leads to them. Here's an odd guy. I don't even know what type that is. I don't know if that's ceramic or plastic film or what. And I saw that again and again. Here's another example of combining what I believe is a Mylar film cap with silver mica cap, another Mylar type I believe, not quite the right value, another one where 2 are stuck together. So a lot of weirdness. So what I've been doing is going through and well, undoing the work. Here's another weird thing where originally there was a film cap here and they took 2 ceramics and put them in parallel. And as for the power supply, originally there were 2 selenium rectifiers here, and the 3 big filter power supply caps are down below. There was a terminal strip here. They used these little silicon diodes for replacements. Some of the original caps are still wired in. A couple were bypassed. Well, I'm going to clean that up, put a new terminal strip in here, and mount new components on there. Got some nice new G-Con caps over here to use. Yeah, so that's where things stand. A lot of weirdness, but no showstoppers so far. Some of the replacement components, like these, are pretty good and were soldered in well, so no reason to not go with those. One control was damaged at some point in the past, so there should be a threaded shaft here with a nut and washer on it, like these two guys. That's gone, and it's being held in place with some sort of silicone, it looks like. It's loosened up a little bit. Well, these controls don't grow on trees. These are made to isolate the high voltage running down here from the chassis, so hopefully that's still good. That will work, and I'll keep my fingers crossed on the rest of it. So I'm just going to keep plowing along, replacing parts as I go, and hopefully soon I'll be ready for a first power-up test. I'm making steady progress working on the set, working on the power supply area right now to be specific, and I just discovered something I really was not expecting. So here's the remains of the silicon diodes that were installed to replace the selenium rectifier as well. Check this out. There's a green wire running off one of the diodes going over to this lug, which is going right to the chassis. The chassis on these VT-71s, the TS4 chassis and the very similar TS-18 chassis, are not ground. They are supposed to be floating. Ground is, or B minus, I guess you could think of it, is a wire running all through the chassis. That's why these filter caps have cardboard on them and they're mounted on insulating wafers. Everything is supposed to be isolated from the chassis. Well, when this guy put in his silicon rectifiers, he tied, well, essentially one side of the AC line right to the chassis. In other words, he turned this into a hot chassis set, which would not only pose a shock hazard, but may very well have introduced a lot of 60 hertz garbage into the circuitry. The chassis is supposed to be floating, and there's sort of like a virtual ground. The only thing going to the chassis on the entire schematic are these two components. See all these triangles you see pointing down? That's your B minus return. And that is isolated from the chassis all throughout the set. There's only a few places we have ground. So they put in these two to kind of create a virtual ground, kind of loosely tied to one side of the EC line, just so it's not completely floating and it's referenced to something. Yeah, so he essentially bypassed that and just shorted these two together. So definitely will not be repeating that mistake. Well, guys, we've reached that point. As much as I enjoy soldering, I've pretty much run out of stuff to replace. Here's what I took out, and well, you can see the new parts all around in here. So that point I mean is the point of trying to power this thing up. So far all I've used is soldering iron, my trusty Fluke 27, and a few basic hand tools and a roll of solder. But when it comes to powering these up, I'm going to get a little more serious and use a Sencor PR57. Not for the variac function, but for the isolation function. Even though this chassis is floating, definitely a good idea to use one of these to isolate the set from the AC line. Yeah, especially since I'm not entirely sure this chassis is isolated from the AC line anymore. I could do a quick check on that though with resistance and check the resistance between either one of these lugs and the chassis. So I'm going to flip this around, use this mocked up ballast. So this has a diode for each of the filament strings plus a series resistor. Notice they're not equal values because when you add up these two filament strings, they are not the same. Even though the original ballast shows equal dropping resistors, they are not the same. There's a few volts difference between the two. And then there's an inrush limiter, it's at 33 ohm there, and then it's a 200 ohm or so between two of the main filter caps. So form a pi filter, so capacitor, diode, capacitor. And then finally, CL90 to give it a bit of a soft start to suppress the surge current when you turn it on. So I'll flip this over, hook this up. I'll do a quick check on resistance between the AC line and the chassis and dig up a cheater cord so I can plug it into that guy and dig up a CRT. And let's see what we can make this thing do. When I hooked up the ohm meter to either side of the AC line, one side I got infinity, the other side I got 470K, which is exactly what I should get, because that 470K there. Turn the lights down a little bit so I'll be able to see the tubes glow more easily, and a slight change of plans. I'm not hooking up the picture tube just yet. Put a dummy load in place of the filament. Now I get asked all the time, what value resistor? Well, come on, use some basic Ohm's law. 6.3 volt filament, 600 milliamp, 10 ohms. Basically, I'm using 15 because that's what I had on hand. It's a little bit more conservative, but anything in 10 to 20 ohm range, just fine. Use 7.5 to 15 watts. And there is my ballast replacement. And I got it plugged into the 57, and I got a speaker hooked up. Speaker is a little unusual in that it looks like it's been painted with hammer tone at some point, but it does have the original Motorola printing on it. All the others I've seen, well, like this one from the other chassis, pull it out here. Alright, the signal generator is boring. Well, a video. Well, a test pattern generator is kind of boring, but I guess it is the most practical thing to use. I fired up my Syncor VG91, which can broadcast a clean signal on any channel. So let's put this on channel 4 and crank things all the way up. Standard TV, 1 kilohertz test signal. There already happened to be an adapter on the back of this set, so it's easy to hook it up. I'm going to turn this guy on. LED line voltage pretty low too. Should have had it up to about 117. It's going to make a bit of a difference, I'm sure. I had it down at around 95 or 100 volts. That was unintentional. I'll turn the radio off. That's distracting. Okay, there's our hum back. Well, I'm just going to go through channels on this. It's easier to change these channels than it is on the TV. Nothing. Try this again. Now I haven't tested tubes. That's a good sign. That's the mixer converter tube, or local oscillator mixer tube. It's a ratio detector tube, I believe. Huh, that tube is ice cold. don't see any filament glow. It's a 12 AT7. That's bizarre because tubes are in series. You can't have one tube not lit unless it's gone gassy. Which is something I was surprised to find out, that a tube can be gassy. In other words, air is inside here, but the filaments don't burn out. They will still keep conducting. And they don't burn out because the air actually pulls the heat away from the tube fast enough that the tube doesn't burn out. The tube feels a little on the cool side too. Yeah, all the rest of them are going. Oh, that guy's, the filament is glowing, it's hard to see. So, let's see if I can do another 12 ATs. Oh, yeah, maybe this is glowing. Yeah, it's really hard to see down at the bottom. Really faint on that side. The other side's even fainter. Well, considering how these filament strings were hooked up with that goofy dropper resistor mounted on top of the chassis, I wouldn't be surprised if the tube suffered some damage. Here's the other chassis I'll be restoring, and this one has a full complement of tubes, so I just grabbed 12 AT7 out of that guy. Let's see what we get. It's a bit dim, but you can definitely see on top. It's a couple pinpoints of light. Hey, and there's my test tone. Cool. So it's 2. Yeah, it's channel 6. Which is basically no antenna because I've got my pattern generator hooked up. Alright, well, no problems so far, so I don't see any reason not to go ahead and hook up the picture tube. Here it is with the 7JP4 CRT installed, and I couldn't help but notice that it's an RCA branded tube. And there was an interesting comment about that online the other day. RCA never made any 7-inch sets. Not a 7-inch set that used a 7JP4. So why are there so many RCA branded 7JP4s floating around out there? Well, all we could figure is that they were replacements, aftermarket replacements. Anyways, let's see what we can get. I'm definitely going to be curious to test this 12AT7. It's a quality one. Jan Phillips tube. It says 8739. That's what it looks like. I really don't think this was made in 1987 though. Anyways, that CRT filament is lit up. Hearing a tone come out of the speaker. Oop. And we've got a raster slowly coming in. Now remember, I've got a CL90 in this rigged up ballast, which slows the power up. Let's see, let me turn it back and try to get to the brightness. Turn that up. Is this guy, or maybe this is focus? Yeah, it's focus. They put brightness right next to the AC line. I was getting really paranoid reaching back around for it. Alright. Adjusting the hold now. See if we can get this thing to actually lock. I think we're way off frequency. It's almost starting to lock here, and it controls it at its maximum extent. Yeah, we got some work to do there. Changing the test pattern. So it's a crosshatch right now. So it looks like the horizontal oscillator is running so far frequency I can't lock. Not so sure about the vertical either. But hey, it's definitely progress. It's a little weak over the air reception. I try swapping out some more tubes, particularly the horizontal tubes, horizontal sweeping oscillator tubes. Nope, I swapped all the tubes and no difference. So some resistor or capacitor has got to be off value so far that I can't get a lock. So next up, we'll be doing some troubleshooting.